Now, what is an easy way to solve this question? 2y raised to power minus half equal to minus 14. This is also a question involving indices, equations involving indices. Now, the first thing I'll do is to divide both sides by the coefficient of y raised to power minus 1 over 2. If I do that, I'm going to have y raised to power minus 1 over 2 equal to minus 7. Now remember, I've divided both sides by 2. It's just to divide this by 2 and divide this by 2. So this 2 will cancel out. And when 2 cancel 14, it will be 7. So that's how I got this. Now this is inverse. So I can express it as 1 divide y raised to power half equal to minus 7. I could cross multiply. This will move to this position and minus 7 will move to its position. And if I do that, it's going to be 1 divide minus 7 equal to y raised to power 1 over 2. So they have exchanged positions. How do I take away this power half 1 over 2? Is to take the square root of the y. That is, take the square root of the y. This is the same thing as square root y. This 1 over 2 became this. And then you have minus 1 over 7. Now, how do I take away the square root sign from here? I'll have to square both sides of the equation. And if I do that, this is 1 over 49. The square root will cancel the square, and this is y. So the value of y is 1 over 49. Now, number 2 question is also indices. X raised to power 5. This is multiplication. Multiply x raised to power n equals to x raised to power 5. Now, the laws of indices says that when you're multiplying, you can add the powers because they are the same base, xx. So this can be rewritten as raised to power 5 plus n. The law, addition law, or the multiplication law of indices equal to x raised to power 5. As long as both of them are the same base, you can add the powers. Now, at this point, you can cancel out the base and equate powers. So if you do that, you're going to have 5 plus n equal to 5. To get the value of n, you call it like terms, take the other 5 to the other side, and your value for n is 0. Now, in the number 3 question, 4x is equals to 0.25. Now, looking at this question, we'd be thinking it's a very difficult thing to do, but it's not. This is the same thing as 4 raised to power x equal to, you can rewrite this as a fraction instead of a decimal number. And this is the same thing as 25 divided 100. So here, there are 2 decimal places. That tells you the number of zeros that will be at the denominator. So since there are 2 decimal places, 2 zeros. And then if you divide this, it's going to be 25 here, 1, 25 here, it's 4. 1 divide 4. You can express this as 4 raised to power minus 1. Inverse. Remember the law of inverse. So the base are the same. So I can cancel out the base and equate the powers so that my value for x is equal to 1. Now, number 4 is another beautiful question to solve. 3 raised to power 2x minus 3 raised to power x plus 2 is equal to 0. Well, what I would do is to take one of them to the other side of the equation. So that becomes 3 raised to power 2x equal to 3 raised to power x plus 2. So at this point, you equate powers, cancel out the base. So it becomes 2x equals to x plus 2. If you collect like term, 2x minus x, this x will move to your left-hand side, become minus x equal to 2. 2x minus x is x. And this is the solution to the question. This is one question that may pose a challenge, but the truth is, just begin to solve and the solutions start coming out. Now, all we need to remember are the laws of indices. Recall that this can be written as 2 raised to the power 2x multiplied 2 raised to the power minus 3. That's the law of the indices. The law of indices brought these together to give you this minus 2 raised to the power x multiplied 2 raised to the power minus 2 and minus 1 equal to 0. So I have succeeded in separating them using the law of indices. This is 2 raised to the power 2x divide 2 raised to the power 3. Inverse law. So this minus is inverse. And so this is the inverse. Divide 2 raised to the power 3. So the minus is gone. Minus 2 raised to the power x. And there's also an inverse here. So it becomes divide 2 raised to the power 2 minus 1 equal to 0. So at this point, we simplify further to be 2 raised to the power 2x. 2 raised to the power 3 is 8 minus 2 raised to the power x. 2 raised to the power 2 is 4 minus 1 equal to 0. So at this point, we can represent 2x, 2 raised to the power x, to be any letter of our choice, but I decide to use p. So this is p squared. Remember, this is 2 raised to the power 2x. And 2 raised to the power 2x can be expressed as p squared. Then the 2 raised to the power x is the p, while this 2 is this 2, the square. Divide 8 minus p divide 4 minus 1 equal to 0. The next thing is to look for the LCM, which is 8. Then you multiply through by the LCM. If you do that, it's going to be 8 multiply p squared divide 8 minus 8 multiply p divide 4 minus 8 multiply 1 equal to 0 multiply 8. So if you do that, you'll be left with p squared. If you divide this, it's going to be 2p minus 8 equal to 0. So you have a quadratic equation. If you factorize this, recall how to factorize p squared multiply minus 8, which will give you minus 8p squared. Now, if you look for two factors of minus 8p squared, two numbers you multiply to give you minus 8p squared, and when you add them, it's going to be minus 2p. They are minus 4p and 2p. If you multiply these two, you're going to get minus 8p squared. If you add them, you're going to get minus 2p. So you replace with minus 4p plus 2p minus 8 equal to 0. So let's factorize. If you don't know, you can check out my other factorization videos. This is p squared. So what's the highest common factor here? It's p. So you're left with p minus 4. Highest common factor is 2. You're left with p minus 4. So if you want to know you correct, what you have in this bracket must be the same here. So you take it out and you have p plus 2 and p minus 4 equal to 0. So at this point, p plus 2 is equals to 0, or p minus 4 is equals to 0, which gives p equal to minus 2 or p equal to 4. Now remember, this is not what we're looking for. We're not looking for the value of p. We're looking for the value of x. So you go back to our solution where we said let 2x equal to p. So in this point, I'll say 2x is equal to p. So when p is equal to minus 2, this will give 2x equal to minus 2. Now, at this point, it's not possible. It's not possible because the base here is 2, but the base here we're having is minus 2. So this is not possible. So I can't solve this beyond this. So I just simply write not possible. I'll try the next value of p, which is 4. So 2x equal to 4, which is 2x equals to 2 raised to power 2. So here I can cancel out the base and equate the power, and x is equal to 2. That's what I'm looking for. And that's the solution to the question. Now let's look at this question, which is similar to the previous one we've just solved, so that it will solidify how to use this method in solving equations involving indices that takes you to a quadratic equation. Again, this can be rewritten as 2 raised to power 2x multiply 2 raised to power 1 minus 9 times 2 raised to power x plus 4 equals to 0. So here I apply the law of indices by separating this expression in the power to become this. Now, the next step is to say let 2 raised to power x be equal to p. So wherever I see 2 raised to power x, put p there. This is 2 raised to power x. That's p. But there's a 2 here, square. So it becomes p squared. This 2 will multiply this. And so this 2 is supposed to multiply p squared to become 2p squared. Minus 9. 2x is p. 2 raised to power x rather is p. So 9p plus 4 equal to 0. So here you have the quadratic equation again. So applying factorization method, 2p squared multiply 4. The method will be easier now. And this is 8p squared. I won't be showing this maybe in subsequent solution. I will just go straight ahead and factorize and getting the values for the factorization. Now look for two terms. When you multiply them, you get 8p squared. And when you add them, you get minus p, 9p. The two terms are minus 8p and minus p. If I multiply these two, I'll get 8p squared. If I add them together, I'll get minus 9p. So I'm going to replace what I have there with minus 8p minus p, then plus 4 equal to 0. So this will be factorized and this will be factorized. Highest common factor is 2p. 2p squared divided 2p, you're left with p. 8p divided 2p, you're left with 4. Here, highest common factor is minus 1 and p minus 4. What you have in this bracket is what you have in this bracket, so you take 1 away. And so you have 2p minus 1 in bracket, p minus 4 in the other bracket equal to 0. So 2p minus 1 is equal to 0, or p minus 4 equal to 0. So p is equal to 1, or p equal to 4. So here p is half. We're not looking for p, we're looking for x. So remember where we say 2x is equals to p. So if p is equal to half, it's going to be 2 raised to power x equals to 1 over 2. And this is the same thing as 2 raised to power x equals to 2 raised to power minus 1, applying the law of inverse. So here the bases are the same. You can cancel out a base and get a value for x to be minus 1. So that's the first. Now if p is equals to 4, then 2 raised to power x will be equals to 4. 2 raised to power x will be equals to 2 raised to power 2. Cancel out the base, equate the powers, and x equals to 2. So here, x is equal to minus 1 or x equal to 2 satisfy the equation. I guess this will not be a problem. Thanks for watching. Remember to subscribe to my YouTube channel. Drop your comments. I really want to get your feedback. And share the video. If there's any question, use the comment section. If there's a topic you want me to teach, use the comment section. See you in the next video.